Hi, good morning, afternoon, or evening, everyone, depending on the world where you're tuning it from. I'm excited to get to talk about incremental data loading into Delta Lake. And this is especially helpful when working with massive data sets in the data lake. And by the time we're done with this session, you're going to taking away some simple techniques how to achieve this in the Delta Lake. So before getting into the nitty gritty of that, let me introduce myself. My name is Puneet. I'm a data enthusiast from Norway, where me and my colleagues has recently launched a group based on Synapse and Fabric-based data engineering. And if you like what you hear today, want you get your hands on data engineering with Fabric, we are hosting an event which has been kickstarted by none other than Astera from Microsoft on 20th June. So feel free to check that out. QR code is on the screen. So what is the Delta Lake thing, which I'm keep mentioning? Uh, if you're hoping for a scenic spot vacation near the lake, I kind of hate to disappoint you. Delta Lake is a super flexible storage layer which brings you an asset-based transactions, scalable metadata and handling, um, and the ability to unify both streaming and batch-based data processing. So it's also an heavy lifter when you're building your lake houses in Synapse or Databricks, and also seems to a backbone of one lake storage layer in the fabric. So think of it as a bucket-based files with some extra logs, which you can also store versions in order to capture the changes, uh, and hence it's going to improve the security and performance and the reliability. So why do we need to perform an incremental loads? Imagine you're a master chef and every day you have to cook like 5 course meal from the scratch, which kind of an exhausting task. So now instead of doing that, you can save some of the prep work from the previous day and only cook what's new or what's the new order you're going to get, which is kind of give you a sense of an incremental loading in a nutshell. So it's all about efficiency. It's all about reducing data transfer, saving some computational resources, uh, kind of make it like a sous chef in your data kitchen. So picture this: if you have one source table uh, that you wanted to load into two target table, and one way you can do is full load, like a dump truck pouring the data from the bronze layer to the silver zone, where you can either materialize the data in between, or from the data frame you can clean, merge the data based on your merging strategy. New comes as insert, maybe old goes as is, or update depends on your flow. In a one way, you're doing the full load. On the other hand, the target gets the new incremental data in a small chunks, like a gardener planting small seeds. This can be a use case where you represent, okay, one process loading all the data every time versus another one using only small chunks at a time. If you flip a scenario a bit, you have two bronze tables merging into one large gold table, maybe aggregated basis. So instead of flooding the target table into full loads from both the sources, what you can do is send only the small incremental changes. So notice that in both the cases, I'm keeping the bronze layer as a pen mode, which is one of the common way of loading data into the bronze layer. So how do we do this? There are several approaches. Uh, the first one is comparison-based approach, where we compare old data versus the new data, or even old logs or versions. But it can be like finding a needle in a haystack. Efficient when you're dealing with small changes, but not so much when you're dealing with large ones. The another one we have is watermark-based approach, where we track only what has been updated last time. It's like marking your place in a book. It can be straightforward, but could be tricky if the updates are not timely ordered. It also generates a need for managing uh, metadata, the tables and their consistency. The third one we have is a change feed, which we only track the changes before you merge them or come as is, or when they happen. Uh, Imagine this as a small news ticker you see in your TV screen. Instead of showing full news, it's only show you the short version of it. Uh, but with the change field, you also need a system to track the changes. The fourth one, which is checkpoint-based approach, using structured streaming. Instead of streaming everything, we only trigger it once, and also remembers or where it stopped last time. like a bookmark, or if you can imagine a Netflix binge watching, you can continue where you left off from the previous episode of whatever you're into, maybe Stranger Things. Um, it's efficient. Instead of focusing on metadata management, you can focus on value creation for the business. It supports by Spark natively. We'll see in the demo as well. Uh, it may need some housekeeping over the time, exactly like you have in your other streaming processes. Uh, yeah. So before we move on, let me show you a demo how this works in Microsoft Fabric. Same you can apply in Synapse. We can take a look at this architecture and a short demo, like a mini field trip. We cover only the red part of the process, showing you both comparison and checkpoint incremental load. We're going to load the data from Azure Open Dataset. So yeah, let's see. So let's talk about the process of incremental data loading into DeltaLake from the Azure Open Dataset. Uh, our data of choice is New York City Green Taxi dataset, and we are loading certain necessary libraries from Azure Open Dataset, and we are enabling certain performance settings that helps us speed up reading the Parquet files in the one lake. The main part of our process involves setting up the parameters for the load type and the date range. So if the delta load parameter is set to 1, that means incremental loading, and we have certain start date and end date to work with. Now the next part is where the magic happens. If the delta table already exists, we fetch the maximum date and set it as a start date and start loading data incrementally. If it doesn't exist, it's going to take the parameter of start date from the parameter field and set the end date as the next month. If the delta load is 0, which means full load, we load the data month by month from start to end, and this flexibility allow us to backfill the data whenever necessary. So we're starting from June, ending in July. This is because the May data has already been loaded. The next, we're defining the schema for NYC Green Taxi data to ensure the accurate data type. Then comes the loading phase. So in this phase, we're loading the data chunk by chunk, or in our case, month by month. We fetch the data for the given month, load into data frame, add some new columns into it, and write it back to the delta table in append mode, and the process is repeated until all the data is loaded. So once the data is loaded incrementally into DeltaLake, we're going to check the maximum date, what has been loaded so far for the sanity purposes. Finally, we're going to vacuum the table to maintain our data retention. And we're going to use the optimize command to manage our file size. That's ensure the data remains manageable as it grows over the time. So yeah, this is the whole process for incremental loading using comparison method, and we comparing what has been loaded before and loading the next iteration accordingly month by month into the bronze layer in a print fashion. And let's jump now to the next notebook, taking this appended data from the bronze layer into the silver layer. So now we're loading the data from a previously prepared bronze layer to the silver layer using the structured streaming, but there is a twist. We'll be triggering it only once effectively, simulating the stream as a batch-based operation. Yeah, so let's get started. First, we'll load the necessary libraries. With these in place, we're gonna generate a date dimension using a custom function. This function takes the start date and the end date and churns out the data frame filled with the dates. We then load this date dimension into the silver layer. This operation overrides any existing data in the table. Then we define certain paths, which is base path, and then create a checkpoint directory path for the checkpoint file. And this file is a key file as it stores the metadata for our streaming operations. It holds the information natively handled by Spark. So like tracking already processed source files, identifying new ones, which is very crucial for loading incremental data from the bronze layer. We now have added an extra feature, which is to reload the data from the bronze layer based on delta load flag. If this flag is set to 0, it checks and removes the checkpoint directory. What does this mean? This means that if we need to do full data reload, we can change this parameter. It will kickstart the checkpointing and initializing the stream. We then define a function here to write the data frame to the NYC green taxi underscore temp, which is our intermediate layer into Delta format in an override mode. So every time a new increments come, instead of upserting them into the silver layer, we store them as an intermediate layer, hence capturing the changes. If the notebook fails at this step, it can still pick up where it left off, maintaining the consistent state. So as we choose to simulate a streaming job as a bash-based operation, we are doing this by setting up this parameter, which is triggered once parameter equals to true. So instead of processing this in intervals, we are saying that just do it one time. This saves us a cluster to keep it running all the time. So we're triggering it only once. Once our data is loaded, we can start analyzing it by this minimum and maximum query. So I have this previous loaded data frame, which is from 1st May to 1st of June. So if I run this again, it's gonna bring us or show us at least the new increment, which I've already appended in our previous demo. So let's see what the result looks like. Yeah, so it's from 1st May to 1st of June, and now it's from 1st of June to 1st of July, which is a new incremental chunk. So now we have analyzed our incremental chunk is doing okay. We can also do certain cleanup operation to disable retention during checks and remove the old data in the table. We can finally enrich the data with the holiday tables. And this is a shortcut table referencing the existing data from my existing ADLS. And you can see it's represented as a link sign here. We enrich the data. We can represent that as a chart to analyze the taxi data, maybe of regular days versus holidays, which can be useful for decision-making processes. We can also bring certain extra libraries if we need to, like grade expectation to validate our data quality control. So finally, with our enriched view, uh, which contains the small chunk of data rather than the large full set, we can add an extra column like job name to enrich it further for the metadata and merge this small chunk data frame to the silver layer on our lakehouse. So finally, there you go. We have successfully loaded the data from the bronze layer to the silver layer using the structured streaming, but simulating as a batch operation and perform some initial data analysis before the merging. So yeah, that was a short demo. And if you're a Databricks user, you can use a Databricks autoloader for incremental ingestion or checkpoint technique that we saw today from bronze to silver layer. Or if you have a use case, you can use proprietary DLT method, hence handling everything from ingestion to incremental updates like a charm. So yeah, there are certain things you need to consider. Few of them are data skew, ensure your data is evenly distributed for efficient processes. Merge strategy, choose it wisely based on your data size and the change rate. Latency, if you have fast update, choose your approach that supports or suits best for your processes. Parallel processing is make sure you use it to speed up your load by parallel processing. Resource utilization, be mindful for your resources. You don't want to exhaust them. So yeah, with that, we've come to an end for our today's session. And as of June 24th, this covers the strategy which I know and love. But this field is always on the move. That means it's always innovating. So don't be surprised if you come across some new strategies or more approaches to tackle incremental data load in the future. I hope you find this insightful. And remember, the key is to always choose the right approach based on the environmental factors you're in. And don't forget to join us on 28th for hands-on data engineering event. And feel free to connect with me on LinkedIn for any question you might have. Thank you for your time.